For a decade, exactly one company on Earth could catch a rocket booster out of the sky and fly it again. That company was SpaceX. That monopoly just ended. On July 10, 2026, China successfully landed the first stage of a brand new rocket, not on legs like Falcon 9, but caught in a net, floating on a ship in the middle of the ocean. And the way they did it might be more important than the fact that they did it at all. Here's the headline version. China's Long March 10B rocket lifted off from the Wenchang commercial space launch site on Hainan Island. It delivered a satellite into orbit successfully. And then, just 6 minutes after stage separation, its first stage booster came back down from space, under its own power, and was caught by a massive recovery structure mounted on a floating platform in the ocean. This was not a suborbital hop. This was not a test flight into empty sky and back. This was a real orbital mission, with a real payload, followed by a real controlled recovery, on the very first attempt. For context on how rare that is, only a handful of nations and companies on the entire planet have ever pulled off a controlled return of an orbital-class rocket stage. China just joined that list. And they didn't just join it. They joined it doing something nobody else has tried. For the last 10 years, if you pictured a rocket landing itself, you pictured one very specific image: a SpaceX Falcon 9 booster, deploying 4 grid fins and 4 landing legs, settling down vertically onto a concrete pad or a drone ship, engines firing in that iconic final burn. That image has basically defined reusable rocket in the public imagination since 2015. China's Long March 10B did not do that. Instead of legs, instead of a landing pad, the booster descended toward an offshore platform and was captured by a large net-based recovery structure, essentially catching the falling rocket the way you'd catch a fish, except the fish weighs tons and is moving at supersonic speed just moments before. Think about what that actually requires. The booster needs guidance software precise enough to hit a moving target at sea. It needs engines reliable enough to restart in mid-descent and rugged enough to survive re-entering the atmosphere after already flying to the edge of space. And it needs all of that to work correctly on the very first real attempt, because there's no do-over when you're threading a multi-ton piece of hardware into a net on a rocking ocean platform. Here's the part that matters most, and it's easy to miss if you just skim the headlines. China didn't copy SpaceX's homework. They looked at the same problem. How do you get an expensive rocket stage back safely? And came up with a completely different engineering answer. One industry analysis put it simply: China has not simply copied an existing recipe, it has proposed one of its own. That distinction matters more than it sounds like it should. Copying a proven design is one thing. Independently engineering a working alternative to a system that took SpaceX years and multiple spectacular explosions to perfect. That's a different level of capability entirely. Picture the actual sequence of events for a second, because it's more dramatic than a headline can capture. The rocket climbs away from Hainan Island, its upper stage carrying a real satellite toward orbit. 6 minutes later, high above the ocean, the booster separates and begins falling back toward Earth. Except instead of just falling, it's flying itself down, using its own engines to slow its descent, using onboard sensors and guidance software to calculate exactly where a moving platform will be by the time it arrives. Then, in the final seconds, it threads itself into a massive net rig mounted on a ship rocking with the ocean swell. Smoke still curling off a stage that, moments earlier, had been in space. That entire sequence had to work correctly on the first real attempt, with no second chances and no room for error. But here's the question nobody's answering honestly enough. Does one successful landing actually mean China has caught up to SpaceX? The answer is more complicated than the headlines are making it sound. And it matters for anyone watching where the space race goes next. Let's be precise about what July 10th actually proved, because there's a real difference between a milestone and a rivalry. China Aerospace Science and Technology Corporation, the state-owned giant known as KASC that built the Long March 10B, said the mission verified technology for reusable transport and set up groundwork toward actually reflying the booster. Read that carefully. It verified the technology and set up groundwork. It did not say they've already reflown a booster. Reflight, actually launching the same recovered stage a second time, is the step that turns a landing from a spectacle into an economic advantage. And China hasn't done that yet. Compare that to where SpaceX already is. Falcon 9 boosters routinely fly more than 20 missions each. SpaceX isn't proving rockets can land anymore. They proved that a decade ago. They've moved on to proving rockets can land, refuel, and relaunch within days, over and over, at a pace no other space program on Earth currently matches. One industry breakdown put it bluntly: China entering the reusable rocket race does not mean SpaceX suddenly has an equal rival. There is still a long way to go before that's true. And this wasn't even China's first attempt at booster recovery, just its first successful one on a real orbital mission. Chinese companies had already reached orbit with reusable-class vehicles like Zhuk 3 and Long March 12A. But earlier recovery attempts didn't complete the landing sequence. In one case, back in December, a Long March 12A booster's braking burn failed, and the stage slammed into the ground roughly 200 miles downrange from the launch site instead of touching down safely. Getting to orbit and successfully recovering the booster had been two separate achievements for China. Long March 10B is the flight that finally combined both into one success. So here's the honest scoreboard. SpaceX has years of head start, dozens of proven reflights, and an operational cadence measured in days. China has one successful capture on one rocket, using a method nobody else has proven can scale. China closed a gap. They have not erased it. To put SpaceX's lead in real numbers, the company has landed boosters well over 400 times at this point, with individual Falcon 9 boosters routinely flying 20, 25, even 30 missions each before retirement. That kind of repeated reuse is what actually drives launch costs down. Not the first landing, but the 100th. China is currently standing at exactly one successful recovery. The distance between "we caught a rocket once" and "we casually reuse rockets dozens of times as a routine business" is enormous. And it's measured in years of accumulated operational experience, not just engineering theory. But here's why investors, the Pentagon, and Elon Musk himself should still be paying very close attention. Because what happens next could matter more than the landing itself. Because this isn't really a story about rockets. It's a story about who controls access to space for the next decade. And there's a company you use every day that's sitting directly in the crossfire. Here's the strategic layer most coverage skipped past. A working reusable rocket isn't just a cool engineering flex. It's the single biggest cost lever in the entire space industry. Reusability is exactly what let SpaceX undercut every competitor on Earth for satellite launches, which is exactly what let Starlink scale into the dominant satellite internet provider on the planet. If China genuinely masters reusable rockets at scale, It doesn't just mean cheaper Chinese satellite launches. It means Chinese satellite communications networks, and even hypothetical Chinese orbital data centers, could start competing directly with SpaceX's Starlink in global markets, particularly across Africa, the Middle East, and Southeast Asia, regions where Starlink has been aggressively expanding and where Chinese state-backed alternatives could undercut on price with government support behind them. For the US military specifically, this cuts even deeper. America's current edge in space isn't just about prestige. It's about the ability to launch satellites, replace damaged ones, and maintain space-based communications and surveillance faster and cheaper than anyone else. A capable Chinese reusable rocket program chips directly at that advantage. It's the difference between the US having the only fast, cheap way into orbit and the US having to share that capability with a rival superpower. And here's a detail that adds real weight to why this timing matters. The Long March 10B recovery came just days after a consortium of investigative journalists reported new documents showing China and Russia cooperating on ways to damage Starlink specifically, motivated in part by how effective Starlink has been supporting Ukraine's military communications during the war. Whether or not those two stories are directly connected, they land in the same strategic picture. China isn't just trying to catch up to SpaceX's technology. They're actively working multiple angles to reduce the West's advantage in space, all at once. The market noticed too. Reuters reported that shares in Chinese aerospace firms jumped after the July 10th recovery news broke. That reaction alone doesn't prove long-term value, but it tells you something important. Investors are now treating Chinese reusable rocket technology as a real, financially meaningful capability, not just a government prestige project to make headlines and fade away. There's a broader pattern worth naming here too. Space has quietly become one of the most economically important battlegrounds of this decade. Not because of flags on the moon, but because modern militaries, financial systems, and communications networks increasingly depend on satellites for everything from GPS precision-guided weapons to global internet access in regions with no fiber infrastructure. Whoever can put the most satellites into orbit, the fastest and the cheapest, effectively controls a layer of infrastructure that almost every other industry now quietly depends on. That's the real prize behind this rocket landing story. Not bragging rights, but infrastructure control. So where does this actually go from here? Because the roadmap China has already laid out is a lot more ambitious than just land one more rocket. KSC engineers have publicly indicated they're going to keep refining the recovery technology on the Long March 10B line with an actual reflight attempt, flying the same recovered booster a second time, publicly discussed before the end of 2026. That's the milestone that would genuinely convert this from spectacle into economics. One captured booster proves an idea works. A second launch of that same inspected, refurbished stage within months proves it's a real, repeatable business model. There's also a bigger mission riding on this success. The Long March 10B shares core technology with its sibling rocket, the Long March 10A. The vehicle specifically designed to carry China's crewed Mengzhou spacecraft. KASK has already unveiled the official insignia for the first Mengzhou mission, and China has stated publicly that it's targeting a crewed lunar landing as early as 2030. Every successful recovery on the Long March 10th rocket family is effectively a rehearsal for the reliability China needs before it puts astronauts on top of one of these boosters and sends them toward the moon. It's also worth understanding this wasn't an isolated, out-of-nowhere success. China had already been building toward this for years, testing an earlier reusable experimental spacecraft as far back as 2020, running ground tests, validating over 50 separate critical technologies for the Long March 10 series, and pushing multiple state-backed and private companies simultaneously toward the same recovery milestone. Long March 10B is the moment several years of parallel, sometimes failed, sometimes partially successful development finally converged into one clean success. And China isn't the only country racing toward this. Multiple Chinese companies, both state-backed giants like KSC and private firms like Landspace with their Juke 3 rocket, have been independently chasing the same reusability milestone, sometimes just weeks apart from each other. Landspace actually reached orbit with Juke 3 before the Long March 10B recovery, but their first landing attempt didn't succeed either. This is effectively an internal Chinese space race happening at the same time as the external one against SpaceX. Multiple teams, same goal, all trying to be the one that makes reusability routine rather than rare. Zoom out even further, and you can see this fits a pattern that goes well beyond rockets. China's broader technology strategy right now is built around exactly this kind of move. Pick an area where a Western company or country holds a clear lead. Throw sustained state and private investment at closing that specific gap, and do it fast enough that by the time the West notices, the gap is already smaller than expected. We've seen this same pattern in EV batteries, in solar panel manufacturing, and now, unmistakably, in reusable rockets. So let's step back and ask the question this entire video has been building toward. Is this the moment the American monopoly on reusable rockets actually ends? Or is it something smaller than that? Here's the balanced, honest answer. Because both the hype and the dismissal miss the real story. The dismissive take, "This is nothing, SpaceX is still years ahead," is technically true on the numbers. SpaceX has decades of head start in raw experience, dozens of proven reflights per booster, and an operational tempo no other space program on Earth is close to matching. One successful net capture landing does not erase that gap. But the hype isn't wrong either, because it's missing the actual significance of what just changed. Before July 10, 2026, exactly one country had a company capable of controlled orbital-class booster recovery on a real mission. Now there are two. That's not a small shift. That's the end of an era where reusable rocket technology was something only one nation on Earth had actually pulled off. Every future conversation about the space economy, satellite competition, and even lunar ambitions now has to account for the fact that this capability is no longer uniquely American. And the method China chose adds a layer most people are missing entirely. By engineering a completely different recovery system, net capture instead of powered leg landings, China has effectively created a second viable path to reusability. If it turns out net capture systems scale better for certain rocket sizes, or turn out to be cheaper to build and maintain than landing legs and drone ships, China could end up not just following SpaceX's model, but improving on it in ways that eventually get copied back. That's the real headline underneath all of this. The reusable rocket monopoly is over, even if the reusable rocket gap isn't. And in an industry where the entire economic advantage comes down to cost per launch, closing even part of that gap changes the competitive math for satellite internet, national security space assets, and the broader race back to the moon, all at once. Let's bring this together. On July 10, 2026, China's Long March 10B rocket delivered a real satellite into orbit and then recovered its first-stage booster using a net-based capture system on a floating ocean platform, a fundamentally different engineering approach from SpaceX's leg-based landings, succeeding on its very first real attempt. It didn't just prove China could copy reusability. It proved China could independently solve the same problem a different way. The gap with SpaceX is still real. Dozens, even hundreds, of proven reflights versus zero, years of operational experience versus one clean landing. But the monopoly on who's even capable of this technology at all just ended. And with reflight tests planned before the end of 2026, a crewed lunar program riding on this same rocket family, and Chinese aerospace stocks already reacting to the news, this is very clearly not a one-off headline. It's the opening chapter of a much longer competition. Let's run through the numbers one more time, back to back, because they tell the real story. 6 minutes from stage separation to splashdown recovery. 0 prior successful orbital-class booster captures for China before July 10th. 1 successful capture on the very first real attempt. A crewed lunar landing targeted for as early as 2030, riding on this same rocket family. And a reflight attempt, the milestone that actually matters economically, publicly discussed before the end of this year. Individually, these are just facts about one rocket. Together, they describe the moment a second country joined a club that used to have exactly 1 member. We're going to keep tracking this story as China moves toward its first booster reflight and as SpaceX responds to genuine competition for the first time in a decade. If this video helped you understand what actually happened on July 10th, not the exaggerated version, not the dismissive version, but the real engineering and the real stakes, hit subscribe, because this rivalry is just getting started. And if you want to see how this same China closes the gap pattern is playing out in chips, EVs, and energy right now, go check out our other recent breakdowns next. This rocket landing isn't an isolated story. It's part of a much bigger pattern. Thanks for watching. We'll see you in the next one.